going to test sod 0 plus 4 minus 2 divided by 0. Hello friends, and welcome back to my channel. Let's look at how to evaluate limit of a radical expression. This numerator here is a radical expression. Square root of x plus 4 minus 2. So there are two methods I'm going to use here. I'm going to find the conjugate of this expression. That's the first method. The second method is going to be the L'Hopital rule. I've talked about the L'Hopital rule before. So make sure you stay till the end of this video. You're going to learn a lot. So the first thing I need to do here is to replace x here in this expression with 0, because we have to test if we're going to get an indeterminate value. So I'm going to sod 0 plus 4 minus 2 divided by 0. So this is 0 plus 4 is 4. Square root of 4 is going to be 2. Then 2 minus 2 is going to be 0. 0 over 0. 0 divided by 0 is 0. So this value is indeterminate. So what I need to do again is to use the first method I said. I'm going to find the conjugate of this expression, the radical expression. Then evaluate this, simplify this before testing again, because x tends to 0. Okay? Then the second method is going to be the use of L'Hopital rule. So stay tuned. Now this is going to be square root of x plus 4 minus 2 divided by x. So when I look for the conjugate of this expression, this radical expression, is square root of x plus 4 plus 2. That is the conjugate. So I'm going to multiply it by this and also multiply the denominator, which is x, by the conjugate. So this is going to be this. So going further, I'm going to put brackets here because this is going to multiply this. Okay, my multiplication sign is already here. The same here. So x is going to multiply this. So remember, if I apply difference of two squares here, because this is minus, this is plus. If I use difference of two squares, this is going to be, because you know that difference of two squares, this is the same thing as this is what it is. A square minus b square is equal to a plus b times a minus b. So if I apply this thing here, so this expression is going to be, I'm going to write it here, it's going to be square root of x plus 4 all square. Yeah, using this formula, difference of two squares. So I'm going to put minus here, minus 2 square, because when I expand this, it's going to be this. Okay, now divided by, remember what lim when x tends to 0. Okay, then divided by, so I'm going to multiply this by this. I'll write x, I'll put brackets, sod x plus 4, then plus 2. Okay, now going further, so this is square root. So this square root is going to cancel this square. So I'm going to have x plus 4 minus 2 square is 4 divided by x brackets square root of x plus 4 plus 2. Okay, so going further here, you can see 4 minus 4 is going to be 0. So I'll have x plus 0 is x divided by, this is x brackets square root of x plus 4 plus 2. You can see this s is going to cancel out this x. I'm going to have 1 here. So this is the same thing as 1 divided by square root of x plus 4 plus 2 here. So going further, so if I put, because x tends to 0, look at it here. So if I replace x here with 0, I'm going to have 1, this is the same thing as 1 divided by square root of 0 plus 4 plus 2 here. So going further, square root of 0 plus 4 is actually 4. So square root of 4 is 2. So 1 over, the answer is 1 divided by, so 2 plus 2 is going to be 4. So the answer is 1 over 4. Using this is the first method. So I'm going to use, the second method is going to be L'Hopital rule. L'Hopital's rule. I talked about it before. So if I apply L'Hopital rule, I'm going to write, this is L'Hopital's rule. So applying L'Hopital rule, it means I'm going to differentiate this numerator and equally differentiate the denominator. Okay, before testing again with when x tends to 0. So doing so, I'm going to differentiate this expression. Remember that this expression, this radical expression, is the same thing as x plus 4 all raised to the power of 1 over 2. That is what it is in indices. Then minus 2. So when I differentiate this using chain rule, I'm going to have, this is going to be 1 over 2 bracket x plus 4. So when I 1 over 2 minus 1, that's going to give me minus half. When you differentiate the core value, which is x plus 1, that's going to give me 1. Remember, whenever you are differentiating a constant, it's going to be 1. So if I differentiate whenever you're differentiating a constant, it's going to be 0. Here, differentiating 4 is 0. Differentiating 1 is x is 1. So minus. So when I differentiate 2, that is 0. So this is, remember that this dot is times, divided by, when I differentiate x here, it's going to be 1. So going further, this is the same thing as, so removing this minus sign, I'm going to have 1 over 2 bracket x plus 4 all raised to the power of half. Remember, this minus sign is gone. Remember your indices. So when you multiply this by this, it's going to be the same. Minus 0 is the same. So I have 1 over 2 bracket x plus 4. This is 4. All raised to the power of 1 over 2. So this is the same thing as 1 divided by 2 square root of x plus 4. Okay, what do I need to do again? I'm going to replace x with 0. Okay, replacing x with 0, I'm going to have 1 over 2 square root of 0 plus 4. So this is going to be the same thing as, so 0 plus 4 is what? Is 4. So I'm going to have 1 divided by 2 sod 4. Square root of 4 is, in mathematics, is 2. So 2 times 2 is going to give me 4. So this is 1 over 2 times 2 is 4. You can see this is 1 over 4. For using the Hopital rule, this was the same thing with this when I use conjugation of sod. When I found the conjugate of this radical expression, you can see how I got 1 over 4. So using the Hopital rule, I got 1 over 4. So tell me which one is the shortest formula, and what do you think? Tell me what you think in the comment section.